On this episode of Newt's World, on February 20th, my grandson Robert and I were in Los Angeles, and we had the pleasure of visiting the Divergent Technologies factory in Torrance, California. I was so impressed by the manufacturing innovation we saw on that tour, I wanted to share the story of Divergent with you. So I'm really pleased to welcome my guest, Kevin Czinger, founder and executive chairman of Divergent Technologies and Czinger Vehicles, the original equipment manufacturer of the world's fastest street-legal hypercar, the 21C. Kevin, welcome, and thank you for joining me on Newt's World.
Well, it's my honor to be on your podcast, Mr. Speaker, and we as a team really enjoyed hosting you and Robert, so thank you for the opportunity.
And I should say for the full exposure to our audience that upon leaving you, we promptly went to In-N-Out Burger and my grandson was able to have animal fries. So I felt that the entire trip was both culturally and intellectually very exciting.
The only thing better would have been going to the drive-in part of In-N-Out Burger with 21C.
That's true. I don't think I'm quite ready yet, although it's an amazing car, which we'll get to. But I want to start out with you because, you know, what you've achieved is amazing, but frankly, you're kind of really remarkable. I mean, you grew up in working class Ohio. You built hot rods along with your brothers. You got a football scholarship to Yale, ended up being an All-American, and then you chose to join the United States Marine Corps Reserves. I mean, you've really had a remarkable life before you got into manufacturing. What motivated you through all that experience?
I think that each of these things had its own unique motivation. But in general, I was the youngest of five in a working class family and the first to go to college. And I ended up, because Ohio is a football crazy place and the Catholic schools are really the football powerhouses in Ohio, I ended up going to a very good Jesuit high school. And in that Jesuit high school, they taught the classical virtues, one of which is the life well lived is finding an area of competition that allows you to express your talents and stretch your talents in the greatest possible way. And that idea of the classical Greek well lived, taught by Jesuit priests of all things, has always stayed in my head as, you know, apart from your spiritual life, the driver of how you use the gifts that you've been God-given, in my view, to their fullest extent. When you went to Yale, I was reading up on this, and your coach, who himself is in the Football Hall of Fame, said that you were the outstanding player he ever coached, and that part of it was your intensity, your commitment. What do you think made you so effective on the football field? Well, you're given this gift of life. You have a short period to use it to the full extent. And I always trained to the max. And part of that training was to kind of figure out what you thought your limit was and push behind that. And I think when you approach life that way, you're not mentally prepared to lose. And so that would happen again and again. I'll give you one instance. You know, we were playing in a game where it was actually nationally televised. It was the ABC game of the week. Keith Jackson was commentating. And I had, in this game, the score was 12-7. We were losing. There were only a few minutes left in the game. I had already blocked 2 punts. The one blocked punt I had, and I played defense, resulted in a touchdown. And the time was running out in the game. It was 4th down. The other side was about to punt. And my coach pulled me over and said, "Stop fooling around. You have to block this punt." And obviously I blocked 2 punts already in this game, so people were keying in on me. And I think you just, at that moment, you're like, this person who is a great person, Hall of Fame coach, believes in me, I will find a way. And so basically what I did is I lined up on one side of the ball, and as they got down, they, of course, wanted to make sure I didn't block the punt, so they moved their blocking coverage over to the one side. Then I moved over to the other side and basically ran straight to the punter, blocked the punt, recovered it on the 1 yard line, and we ended up winning 13-12. So I think those things are really just a matter of believing in yourself and feeding off of the belief of others in you and respecting that belief.
Then you went on at Yale to Yale Law School.
Yes. So, originally I was thinking of getting, after I graduated from school, an MD, PhD. And then having worked in a lab, I decided not to do that. And I met a person who was later the dean of Yale Law School, Guido Calabresi. And we actually went to the same church in New Haven, St. Thomas More, which is a Catholic church. And he said, "What are you doing?" And I explained to him, and he was a football fan, that I had been working in the Yale Med School lab, and I had decided I didn't want to get an MD, PhD. And he said, "Why don't you come to Yale Law School?" And I'm like, "I don't know anything about law." And he said, "Kevin," and this is the first time I'd heard of this school, he said, "No, Yale Law School is the L'École Normale Supérieure of America." And I said, "Well, what do you mean?" He said, like in France, that's where they send people who are thinkers, who find their own way to lead in some way in France. And here at Yale Law School, which at the time only had about 125 students in each entering class, he said there were only 4 required courses at the time, and they were all pass-fail. And they said, you want to study science, you want to study philosophy, you can study anything after those 4 courses. And so I thought, well, terrific. And then I went to Yale Law School.
Our mutual friend, John Thornton, tells the story that you went on to become a lawyer and that they got this call one day that one of the great defense attorneys in New York called and said, "This young guy just beat me in court. And I can't believe how really, really smart he is." He said, "You guys at Goldman Sachs ought to grab him." And so you leave Yale Law School and you become a deputy U.S. attorney.
Well, what happened was I left law school. I had been an editor of the Yale Law Journal. It's like being on the law review. And at that time, kind of the usual sequence, and I didn't want to become an academic, but my mentor, Guido Calabresi, who at that point was the dean of Yale's Law School, said, there's a judge who's been assigned the Iran-Contra cases, and he's looking for a clerk. He only takes 1 clerk a year. His name was Gerhard Gesell. He's a District of Columbia U.S. District Court judge. And so I went to work for him for a year. I got a top secret clearance, all of the sensitive compartmented information clearances. As somebody from a working class family, this was incredibly interesting. And I got to work with this judge for a year on this case. And basically what happened was that at that point, I was actually thinking of going into business or doing something other than law. And the judge said to me, even if you go and do business as you said you want to do, being a trial lawyer will teach you a lot. And I said, "Judge, I'm 1 year out of law school. How do you become a trial lawyer?" And I remember he picked up the phone and called up Rudy Giuliani, who was at the time the U.S. attorney for the Southern District of New York, and said, "Rudy, I've got this guy. You've got to hire him." And I remember it was around noon. He's like, "I'm sending him up on the train from D.C. to New York." And Rudy hired me. And over the course of 3 years, in all of the cases that I had, I won top count convictions, including against some of the top lawyers. And then that's when that call took place to John Thornton.
So you then end up going over to Goldman Sachs, which is a totally different career.
It is. And I ended up working directly for John Thornton. And I'd say at the time, and he was really progressed to running the international operations of Goldman Sachs. And I was really his point execution person and person that kind of anything that he needed really to get done from a deal standpoint, everything from the merger between B Sky B and Sky Television into Sky in the UK, to representing Lee Ka-sing in the sale of Star Television, all a wide variety of different transactions and setting up offices and things. And so over the course of 5 years working with John, I learned a tremendous amount and was able to interact with people directly, like a Rupert Murdoch, on transactions.
John says that he told you when he offered you the job that you'd last about 5 years because it just wouldn't be dynamic enough for you, that you'd ultimately want to go do something more that was under your control. So at the end of 5 years, this is, after all, one of the 2 or 3 greatest investment firms in the world. What led you to then leave Goldman Sachs?
I remember I was in Kowloon. It was late at night. Rupert Murdoch had summoned me to talk about a transaction that he was on the other side of, and he was there with the lawyer that he had. And I remember we had this long conversation. It was late at night, and we were just talking in general, and I remember him saying, these businesses aren't life and death to me. It's much more important than that. And then I started talking to him about being an entrepreneur, and he's like, why are you doing this? And I then, what do you mean? I'm at Goldman Sachs. It's like, no, like someone like you really should be creating something. And I thought, okay. I thought more and more and more, and that led me.
So you then decide to co-found Coda Automotive, which is an electric vehicle manufacturer. This is about 2008. But that becomes for you a real evolutionary process from where you first thought about it. As you got into it, you really began looking at the whole notion of what is a sustainable production system, not just what is a sustainable fuel. Talk about that problem. I think it's a very interesting evolution and very important.
I learned a couple of very big lessons, which resulted in me founding Divergent Technologies. One of the lessons was, I would say, that around kind of 2007, 2008, we were focused on building an affordable EV, but the first thing we looked at was battery cells. And I'd say we were the first to work with and generate with a battery company a large format prismatic lithium iron phosphate cell. That is the cell that China has scaled up with. That company, originally, I tried to build the battery factory in Ohio. And because the U.S. at that time, and I would say during the Obama administration, Secretary of Commerce Gary Locke, they were all, hey, if you can't build in the U.S., China is our partner, you should build this factory in China. That factory was set up, and if you look on YouTube and you put in Coda and Gary Locke and Kevin Czinger, you'll see it's about a 2-minute video of me giving a tour of that factory. That gave China what I think was the decisive edge in scaling up battery production. That is what CATL licensed and scaled up, that battery cell technology. When I was doing that, as it relates to China, I looked at the CO2 emissions that related to manufacturing in China. And as you know, China uses dedicated coal power for manufacturing. When you manufacture a battery cell using coal-fired power, which is what is used in China, the emissions from that are greater, I'd say, for the average, say, a 90 kilowatt hour battery pack in a car. You're generating over 200 kilograms of CO2 emitted per kilowatt hour. That manufacturing is greater than, say, driving a Toyota Camry with all of its manufacturing emissions plus 80,000 miles of driving. And when I realized that, I realized that how you manufacture something and how you look at extraction, processing, manufacturing, then the actual use of fuel or electricity, and then disposal, that life cycle assessment, which this analysis has also been done by Goldman Sachs in a very good report called Electric Vehicles Enter the Life Cycle Assessment Era. That kind of uncovers whether these vehicles are environmentally friendly or not. And a lot of it has to do with where you manufacture that battery cell and what the power source is. I'll stop there. I can then tell how that informed the next company that I started.
This is the evolution, although I want to take a brief detour, because in the middle of all this, you're also in the Marine Corps. I mean, how did that fit in?
Well, I don't want to test the patience of your listeners, but what happened is in between my deciding to go to Yale Law School and entering Yale Law School, I had some time, and my older brother during the Vietnam War served in the Army. Both my parents served in World War II as enlisted service people in the Army Air Corps, which was the predecessor to the Air Force. And educated as I was by Jesuit high school and Men for Others, and one of the books that I read in high school was a book by William Manchester called Goodbye Darkness, about his service in the Marine Corps as an enlisted Marine during World War II. And my parents never really talked about the war. My brother didn't either, but I thought as a citizen, this is something where I've gotten these benefits where I should do some service. And so I enlisted in the Marine Corps Reserves and went through Parris Island Boot Camp, Camp Lejeune for advanced infantry training. And then because I was being assigned to a special operations unit out of Quonset Point Naval Air Station in Rhode Island, I had to go through jump school at what at the time was called Fort Benning, Georgia.
You're clearly a guy who fills up every day with something. So now we're back to the real breakthrough, which is the focus on processes. And I have to say, having visited Divergent, someday you're going to have to set up an entire tour service to be able, you're going to have so many people want to come see this, because when you see it and you realize how you have integrated artificial intelligence with 3D printing, with robotics, with very sophisticated use of materials, this is the factory of the future today. I mean, you have leapfrogged over virtually every potential competitive system. Did that just come to you, or how did you put all of that together?
I mean, what happened was with the automotive and battery company, I had been living in the Bay Area, so in the Silicon Valley area, and I had had interaction, had a couple of discussions with Andy Grove after he had retired from being chairman CEO of Intel. And I'd say we both shared, I told him about my frustration with the inability of finding capital to build a factory in the United States. And we also looked and said, hey, and this feeds into obviously a focus and passion of President Trump and both his administrations. From a trade policy standpoint and from a funding standpoint, we were looking at Silicon Valley, and if you had some hardware aspect to your tech startup, unless it said, and by the way, we're going to outsource manufacturing to China, you didn't get funded. And we saw things because of these trade policies, because of the nature of that type of capital. We were, for example, having an Apple transfer process manufacturing IP, like critical advanced manufacturing IP, over to China. And companies like Foxconn start to build a next generation of manufacturing ahead of the United States, as well as move manufacturing capacity over to China. In the 80s, I think must have come out in the late 80s, that book by Paul Kennedy, The Rise and Decline of Great Powers. It was clear to me that no leading power maintains that position if its industrial capacity is less than its peer competitors. Today, we're in Elon Musk talks about fork in the road. I mean, we're in a manufacturing fork in the road more than anything else. We're in an existential fork in the road. China, in 2000 had 7% of global manufacturing market share. It's now trending toward 45%. The US had 25%. It's now trending toward 11%. The US plus all of its allies have not only less overall industrial manufacturing capacity than China, they have less advanced manufacturing. That is unsustainable. I looked at that at a slightly earlier point and said, all of the things that I know about, machine learning, automation, manufacturing, if you were going to start with a clean sheet of paper and reindustrialize the US, because at that time I said, we will lose our position as a leading nation state if we do not reindustrialize. But we can't go back to what we were doing before. We can't go back to the way things are or were before we offshored our manufacturing. We need to make a leapfrog, the kind of leapfrog, say, JFK made when he brought in Wernher von Braun, the rocket scientist, and said, how do we catch up to the Soviets? And Wernher von Braun said, you will never catch up to the Soviets by going to Earth orbit. You need to go to lunar orbit and develop the technology to do that, right? And that in turn obviously created semiconductor industry, many different things. I simply said, you can't do Industry 4.0. You can't do what Foxconn and Apple have done with CNC machining and automation. You need to completely leapfrog that with a total digital system. And if you're starting a company, the first thing you ask is, what's the biggest problem you can solve? And I looked at things like car companies, which obviously go through these peaks and valleys, which we saw in 2008-9, because their factories are design specific. Huge amount of capital goes into designing a single model type, both for the vehicle and then the factory, right? So design specificity. And so I said, okay, what happens if you solve that problem at a given price point by creating a fully digital system? Machine learning generates a structure. That structure then gets printed with fidelity. The way that it's printed, it gets printed in assemblable blocks, and then an automated system assembles those. And that's a super simplified version of what we're doing. But that in turn allows you in a non-design specific way to design any kind of structure for air, land, sea, and space vehicles, generate that structure, have it be a far better, lighter, better performing structure, be able to print it off the same equipment, and then be able to assemble it off the same equipment, whether it's an Aston Martin Vantage frame or a Lockheed Martin cruise missile system. You can design, print, assemble both of those back to back.
As you developed this, the Divergent factory I saw, if I understand the story correctly, is the result of 11 years of evolution, in which now Divergent has 520 patents, and your son Lucas, who's a great story in his own right, has 50 of them. So you guys have been methodically solving problems one step at a time and just gradually building this system, if you will, until now it is, I think, unmatched by anything else in the world.
What I'd say is, not meaning to correct you, but we have about 750 patents today. I'm the lead inventor with about 200 and I think 222 at last count. Lucas has around 80 now. He's my son and partner in the business. What I'd say is about 3 years ago or 4 years ago, we had the first version of the factory that could be commercialized. And since that time, this has gone into production. So automotive, which obviously you're doing the safety performance structures for passenger cars, right? This is enormous risk if you're not manufacturing properly those structures for those vehicles. We brought in as customers, for example, we're shipping frames to Aston Martin for a variant of the Aston Martin Vantage today. But Aston Martin, Bugatti, an Italian company I can't name, McLaren, Mercedes, AMG, and a German company I can't name, those are all production customers. So we actually proved 3 years ago this system was fully commercial. and are now shipping structures and on production programs with 6 major automotive brands. Obviously, the system is an adaptive system. So we take all of that data generated by the system, and the system is versioned, the software and hardware. But what you saw is now a factory that is ready to scale, and which we want to take from that initial factory to tens and then hundreds of factories. So literally every single state in the United States could have multiple digital factories across the country.
You know, if I could just take a minute to stay with the Czinger cars, because as I understand it, when you approach the big auto companies, they were too slow and too timid. And so you just decided you'd build a car to show them it could be done. And I have to say, I was out in your car factory, and it's pretty breathtaking. I mean, these are amazing cars. Can you talk just for a minute about the whole notion of the Czinger vehicle models and the way you've approached this? Because it's quite an amazing story.
Yeah, so going back, probably if somebody did a Google search, they would see when I was a company of one, I bought one of these archaic commercial 3D printers and worked and built a first prototype car that was called the Blade. From there, we then used that as I hired people and started to scale as a laboratory, as a development platform. And about 3.5 years ago, Lucas, my son and my partner, said, "Dad," this is how we really became, the two of us are kind of founders of the car company, which is owned by the tech company. He said, "Why don't we turn that platform into a car company? We can do it with almost no capital because you're almost like an Apple. You know how Apple is a fabless product design company? It uses others for that fabrication. We could use the tools of Divergent and the factory of Divergent to rapidly design the most advanced vehicle in the world, take it through crash safety, take it through emissions, which we did in all 50 states, including California, and then take it to the track and show that it is faster than any production Ferrari, faster than any production McLaren, faster than any production Mercedes or Porsche, meaning street legal car, which we did. We shattered the Circuit of the Americas record in Austin, the Goodwood Hill Climb record, the Laguna Seca record. Now that car in a factory, which was set up by Andy Lampert, Elon had hired him over a decade ago to set up manufacturing and production at SpaceX, and he ran that for about a decade. Andy came over to us, and he's now set up our production factory for the Czinger 21C. And as you saw, cars are now rolling off and being shipped to customers. And that is within a period of time that no auto company in the world could match. We designed, built, and are shipping the most advanced, highest performing production car ever. And it's American made. It's off American patented technology. And we call it the 21C after 21st century because this is like 21st century American muscle car.
And as I understand it, it produces something like 1,650 horsepower and can go about 210 miles an hour. And it's street legal.
It's completely street legal. You know, it's been through full crash, full emissions. The car is about a 3,000-pound car. It's got 1,350 horsepower, all-wheel drive, 2 EV motors up front, our own design V8. We designed and built our own V8, much of which is printed. The top speed of the aero body car is 253 miles an hour. The car does 0 to 60 in 1.88 seconds. What I'd say the most impressive thing, though, is when you take the car to the track and like reference tracks that are the famous tracks, it way outperforms any production car ever built by any of the great European companies, whether it's a McLaren or a Ferrari or a Bugatti. It is in one very short period of time. You see that Ford versus Ferrari. This was Czinger versus the world, and the world was defeated.
I really want our listeners to understand What you have built is a process system using the most advanced technology in the world and integrating it synergistically so that each of the breakthroughs reinforces the next breakthrough. But can you just walk us through a little bit of what happens and how is it done at what you would call the Divergent Adaptive Production System?
Sure. So the system has three subsystems. One is a machine learning-based generative engineering engine. One is a printer that takes what that engineering engine generates and with fidelity in 3 dimensions prints that structure. And then an assembly cell that takes those component structures and puts them together, say, into a full vehicle structure, whether it's a large drone, a collaborative combat aircraft, or the chassis of the 21C. So how that works is, say, you have an Aston Martin or a Lockheed Martin. Let's take Lockheed, because a big focus of ours right now is aerospace and defense. They may come to us and say, we've got a modular cruise missile system. Here are the requirements. Here are the engineering load cases, the stresses that it'll have when, say, it's something that is launched from under the wing of an airplane. Here are the loads when the plane is carrying that off a bomb release unit. Here are the stresses when it gets released. Here are the thermal requirements, vibration. They give us those requirements. At that point, Divergent takes over design authority. And really, the machine takes over design authority in that we then take those requirements, we put those into the machine. The machine runs a simulation of the performance of a structure. It also runs concurrently the generation of manufacturing instructions and assembly instructions. It's called bidirectional evolutionary structures optimization. The machine is adding and subtracting material in a simulation until it creates a perfectly optimized structure, perfectly Pareto optimized structure. At that point, the machine has fully optimized the structure, both for its performance, but also for its manufacturing and assembly. So say I'll take an example, McLaren would ordinarily take 6 to 9 months to do the design for a suspension component for their new hypercar. This is all out in the public domain that we're working with them. We replaced that 6 to 9 months and an engineering team with about 15 hours of compute time. And at the end of that 15 hours of compute time, they have a structure that's 20 to 40% lighter, stiffer, outperforms the structure, is lower cost, and that structure has its manufacturing and assembly instructions, and we can immediately manufacture and assemble it. This is a machine for taking a design, minimizing material and energy in its building, maximizing its performance, lowering its cost, printing it off a machine that doesn't care whether it's printing for Aston Martin or Lockheed Martin, and then an assembly system that assembles the assemblable blocks that doesn't care whether it's manufacturing or assembling for Aston Martin or Lockheed Martin. We in turn charge for that engineering, and then we charge per piece for what we deliver to the customer.
You had actually done work for General Atomic, which produces the Predator, among other things, and which is a very, very sophisticated company. And they came back with results of your intervention that was so amazing, and they're such a serious firm, that it really sort of stopped me in my tracks and made me think about, how big a breakthrough that this potentially is.
Yeah, so 2+ years ago, General Atomics reached out to us. They asked us to re-engineer one of their smaller unmanned aerial systems. And we were able to, in a very short period of time, reduce the part count by 98%. So things like fuel tanks, instead of being separate with brackets and attachments, they actually get printed into the structure as an example. That's how we reduce 184 parts in that drone to 4 parts. So 184 to 4, 98% part reduction. We reduced the production cycle time from 12 days to less than a day, like over 90% reduction in production cycle time. We reduced the per unit cost by over 40%, and we reduced the development cost by over 50%, and the development time by about 95%. I'd say more recently, we have contracts with almost every single major U.S. defense prime and aerospace company. We were able to, on a modular cruise missile system, from the start of engineering to successful flight testing, it took 10 weeks. That 10 weeks would be compared to years in a normal process. As an example, General Atomics, after we did that, actually published the results in a press release. Immediately, we had almost every single major U.S. defense prime reach out to us, and that really kicked off our involvement in aerospace and defense.
Basically, if you think about the fact that you're universally applicable, I mean, what you do doesn't actually matter which particular product, because you're taking the basic same approach. I saw a note that said that potentially on a worldwide basis, this is like a $5 trillion market.
Yes. This company, I'd say we don't want to get ahead of our skis. We've got one factory. We do have 6 major auto brands doing this. I don't think any of them thought this would happen for another decade or more. We have almost every single major U.S. prime. I'd say for the U.S. on the defense side, our Achilles heel right now is inability to rapidly develop and then manufacture at volume. This system solves both of those problems today, is scalable today, and the same factory that is printing missiles and torpedoes and collaborative combat aircraft can also print for Aston Martin and Bugatti and McLaren and Mercedes off of the same equipment all at the same time, or we can do replacement spare parts for defense aircraft, for jets, jet fighters, other things that need it. We can develop new weapons. We can re-engineer old weapons. But this gives us, in my view, the only plausible real deterrent to China. And that is very rapid development of the new kind of weapons that people like Elon Musk and the Defense Department talk about, unmanned air, land, sea, and space vehicles, the ability to rapidly develop those and then immediately scale manufacturing in a distributed way. And also the ability, if you look at our defense budget, which is over $800 billion, $300 billion of that is for sustainment, replacement parts. These new machines can digitize those parts and, as needed, manufacture those parts. We're already doing things for the C-130 right now, spare parts. That means that you could massively reduce those sustainment costs while massively increasing the readiness of aircraft. So I think there's a very, very, very good fit there. And as you said, that kind of design agnostic equipment allows you to save money, create higher performance products, and have the kind of volumes of missiles and other armaments and munitions that actually will deter China.
I think back to the book by the chief logistician in the first Iraq war, who talked about moving mountains because the sheer volume of stuff we send forward, and as you saw in Afghanistan, the amount of stuff we leave behind. In this model, you could imagine a specific divergent factory that moved into the field with the expeditionary force and provided real-time manufacturing on site that could actually take virtually every spare part that they needed and simply do it digitally right there, cutting out all sorts of the logistics tail and also only producing what you need.
Exactly. Not keeping excess inventory. I think distributing out factories to different theaters certainly would functionally allow this system to do exactly what you're describing, Mr. Speaker.
One last question, which is, you're really one of the most interesting and smartest people I've met in a long career of meeting a lot of interesting people. What keeps you up at night? What do you worry about the most?
Well, I have a concern and I also have optimism. My concern is, and I'll say 2 years ago, when I first did this with General Atomics, my view of the military industrial complex, or whatever you want to call it, the defense industrial base, how's that, was one that comes from probably the first Gulf War, which is we just have overwhelming technology and capacity. I've now seen that defense industrial base has suffered the way the rest of our commercial base has, and even worse, from moving our supply chain offshore. We don't have, and it's not a secret because almost every single congressional hearing, and we just testified recently in front of Senator Wicker and the rest of the Senate Armed Services Committee about this problem. We don't have the industrial base that is here to not only develop new weapons rapidly and then volume produce them, but even for our existing weapons. We don't have the casting suppliers onshore. We don't have this supply chain. And the reason I've focused so much now on defense is I think we're at an existential moment. This is the last best chance we have to leapfrog Chinese manufacturing technology and catch up with that manufacturing. And I think what you saw, respectfully, is that solution. So my fear is that will not be identified rapidly enough. People won't fully understand what you've seen. They can only really do it by spending enough time to do it. People will look and somebody says, oh, that's 3D printing. We are far more advanced than any 3D printing system commercially available. This is really a fully digital engineering and manufacturing system where all the software and hardware has been developed as a full system. It's moving from the typewriter to Mac desktop publishing in one step, and people have to really understand that to see that. So my concern is about the adoption of that and the bureaucracy within the military that would look and say, oh, we don't understand this, therefore we have to put it through whatever long process we need to make sure that we smash it from a square peg into something round that we can stick into our round hole, and it takes up time and loses the jump on the Chinese that we have right now. I'd say my optimism comes from the reason why President Trump's administration has tariffs is they want to bring manufacturing back to the United States, right? We were a great country. I grew up, obviously, parents of the greatest generation. I grew up in Cleveland, I'm 65 now, where manufacturing you took pride in. America made things, right? That's a lot of our dignity in the middle class came from that. We've lost that. The tariffs, for example, and trade policy, that was to really rebuild that manufacturing. This is the solution to do it. So my optimism is that we have an administration that I think in a productively disruptive way, I hope through people like yourself, Mr. Speaker, who do come and see it, who do take the time to understand this is one of one in the world and is something that the United States needs to take from 1 to 100 to 1,000. My optimism is that that can happen.
Well, my hope is that, and I think President Trump and Secretary Hegseth may be up to this. You know, in World War II, we went from a jump start, and it was astonishing how fast we ramped up. And I think that you are the first system I've seen which gives us the opportunity to ramp up in a similar kind of way and to, once again, leapfrog past all of our competitors in a way that just leaves them behind. So, Kevin, I want to thank you for joining me. I think of you not only as extraordinarily bright and hardworking, but a genuine patriot, somebody who has spent most of your life developing a system which could, in fact, be the difference between survival and failure for the United States. And I want to let our listeners know that they can learn more about the groundbreaking work you're doing at Divergent Technologies by visiting your website at divergent3d.com. And if they like cars, they ought to check out the Czinger vehicles at Zingerr.com. And I just want to thank you for taking this time out of your extraordinarily busy schedule to help educate us.
Well, thank you, and God bless you, Mr. Speaker, for all you do and for supporting us.
Thank you to my guest, Kevin Czinger. You can learn more about his company, Divergent Technologies, on our show page at newtsworld.com. Newt's World is produced by Gingrich 360 and iHeartMedia. Our executive producer is Garnsey Sloan. Our researcher is Rachel Peterson. The artwork for the show was created by Steve Penley. Special thanks to the team at Gingrich 360. If you've been enjoying Newt's World, I hope you'll go to Apple Podcast and both rate us with 5 stars and give us a review so others can learn what it's all about. Right now, listeners of Newt's World can sign up for my 3 free weekly columns at gingrich360.com/newsletter. I'm Newt Gingrich. This is Newt's World.